Okay, I am Janani from SKR Engineering College, Department of Civil Engineering. My lecture today is about the superelevation. Okay, the topics that we are going to discuss today is why we need the superelevation, what do you mean by superelevation, and the expression for the superelevation. Then, while traveling in a straight road, horizontal straight road, the radius is infinity. Okay, if the radius is infinity, the radius is infinity, the centrifugal force is obviously zero. Okay, so when a vehicle moving in a straight road, horizontal straight road with a radius infinity, the centrifugal force develops will be zero. If the centrifugal force is zero, then there will be no effect of overturning and the skidding effect in the horizontal road. Hence, the driver can take the vehicle with the design speed without any danger. If the vehicle moving in a horizontal curve section, consider this is the vehicle. Okay, if the vehicle moving in the horizontal curve section, this is the outer wheel. This is the outer wheel and this is the inner wheel. Okay, in horizontal curve section, the radius is very low. Say 100 meter, 200 meter, 300 meter. If the radius is very low, the centrifugal force will be very high. Okay, if the vehicle, because the centrifugal force is inversely proportional to radius and directly proportional to the velocity. That is, if the vehicle move with a very high speed and with low radius, the centrifugal force develops will be very high. So, if the vehicle moving in a horizontal curve section, the centrifugal force is very high in the outer wheel. Due to this high centrifugal force in the outer wheel, the vehicle will tends to overturn like this. Okay, in order to avoid this overturn as well as the skidding effect, we can go for the superelevation. Okay, in superelevation is nothing but to introduce the centripetal force. This is a centrifugal force. In order to counteract this centrifugal force, we are introducing the centripetal force by means of introducing the superelevation. Superelevation is nothing but rising this is the transverse section of the road. By rising the outer edge of the road is rise with respect to the inner edge along the transverse direction. The rising of the outer edge with respect to the inner edge along the transverse direction is called as the superelevation. Just nothing but the transverse slope. The main aim of introducing the superelevation is develop the centripetal force. To develop the centripetal force in order to counteract this centrifugal force, in order to eliminate the overturning and the skidding effect. Okay, in order to derive the expression for the superelevation, the basic logic applied to derive the superelevation is summation of all the forces along this transverse, algebraic sum of all the forces along this transverse direction tends to zero. The forces in the transverse direction is W sin theta, and then here the bottom of the tire, the frictional force will exist. F1, F2 plus P cos theta, which is equal to 0. This is the only basic logic applied here to derive the expression for the superelevation. And then convert this W sin theta plus the frictional force in the civil engineering is mu R1 plus F2 is mu R2, which is equal to the P cos theta. Then W sin theta, the mu is in terms civil engineering, the mu can be indicated as Poisson ratio. So I'll change this symbol as F. F R1 plus F R2, which is equal to the P cos theta. Then W sin theta plus F R1 plus R2, which is equal to P cos theta. Then R1 is nothing but the normal reaction, which is called W cos theta and then P sin theta. R1 is W cos theta and then R2 is P sin theta, which is equal to P cos theta. Then group this term as W and then centrifugal force. Fw cos theta plus Fp sin theta which is equal to P cos theta. W sin theta plus FW cos theta. Group the weight as one term and then take this term in the right side. P cos theta minus FP sin theta. Take W common, then sin theta plus F cos theta, which is equal to P into cos theta minus F sin theta. Sin theta plus F cos theta, which is equal, divide by, take this term here, minus F sin theta, which is equal to P by W. Divide this whole total term by cos theta, sin theta by cos theta, plus in order to get the super elevation. Divide by cos theta, divide by cos theta minus F sin theta, divide by cos theta, which is equal to P. P is nothing but the centrifugal force, which is mv square divided by r. W is nothing but the weight, which is called mg. Tan theta, which is nothing but the super elevation, F divided by 1 minus F tan theta, which is equal to B square divided by GR. Tan theta can be represented as E. E plus F divided by 1 minus EF, which is equal to V into, it is in kilometer per hour, convert it into meter per second. 1000 divided by 60 into 60, the whole square, divided by 9.81 into R. So, the 1 minus, as per IRC, the code which is used in the road is IRC. In IRC, the maximum limit of super elevation is 0.07 and the friction is 0.15. Substitute this value here, 1 minus E into F, which is equal to 1 minus 0.07 into 0.5. If you substitute, calculate this term, you will be getting as 1. So, this whole term become 1. Okay. The final formula we are arriving is E plus F equal to V square divided by 127R. This is an expression for the super elevation. The basic logic applied to derive the super elevation is the algebraic sum of all the forces along the transverse direction is 0. Then the total value should be less than 0.07. If the value is less than 0.07, hence it is safe to travel in that road.